Hey guys, this was planned for Wednesday. We're done with chapters 1 and 2, and I decided this would be a good time to do the review rather than doing it in class. You guys can do this at home. So this is your assignment. This is your study guide for the upcoming test on chapters 1 and 2. We're going to go over all the concepts, and this is going to be your primary study source for this exam. Okay, so we're going to go ahead and we're going to get started. We're going to go through these one by one by one. You can also refer to your notes. All these things are in your notes, but we're going to go over them also in detail here. So these are all going to be multiple choice questions here. These are all going to be short answer questions. We'll get to the coding down below when we get there. So let's go and tack each of these concepts. So a microcontroller. What is a microcontroller? We really can't see what the microcontroller is, but this is the brain. And it's the brain that's inside the motherboard. It's the brain, it's inside the motherboard. This is where all the processing takes place, okay, with the ones and the zeros and everything. So this is where all the processing of information takes place. That's what the microcontroller does. It's, there's a little part of the microcontroller with the microprocessor which takes the ones and the zeros and it converts that into messages that you can see on the serial monitor, for example, or it helps to code for the motors to go forward. So that's what it does. It does the work for you. What's a chassis? A chassis is a frame. This is the steel body. The steel body, or it's the frame of the robot. So that's what the wheels attach to, that's what the board attaches to. Okay. Robot parts with wheels and ball, and how to tell if the robot is moving forward. Well, the wheels, these are going to be towards the front of your robot, attached to the chassis, and the ball, this is the back. Okay. Also, you can tell the white breadboard. The breadboard is in the front as well. Breadboard in the front. That's what all the sensors are going to be attached to. Name for the written code, simply called a sketch. You guys have been keeping a sketchbook and naming all of your sketches, and that goes in the sketchbook. Function of the serial monitor. This shows messages and information. Shows messages and information. You guys have been sending very specific messages of hello, numbers, your name, and when we start to get to the sensors are going to be sending information to the serial monitor to tell you if they are working or not. And if they're not, then we're going to have to check the circuitry or perhaps the sensor itself to see what might not be working. So it's a way of testing our sensors coming up in the future. What do these slashes mean? I don't know if we went over this in detail. I've talked with some of you about what these slashes mean, but this is a symbol that is used to write comments. So you'll have your code on the left-hand side of the sketch. On the right-hand side of the sketch, you'll see these symbols, and that means it's just going to be some type of message. So your code is on the left, and then of course it's going to be having a semicolon, and then you might see these slashes that look like this, and this is just simply comments. It's not part of the code. So it's not part of the code. It just simply says, I am moving the robot forward with this code, or this is coding for a 1 second delay, things like that. So that's what those slashes are used for. You don't actually need to use those unless you'd like to use them possibly when we get to more complex coding. The significance of the curly braces, and what do they look like? They look like this, okay? Remember, your code gets written on the inside of it. So this begin and ends a code. Begins and ends a code. Significance of the parentheses. This holds a numerical value. It holds a numerical value. For example, 1,000 for a time, that would indicate 1 second or 1,000 milliseconds. The function of resistors. Resistors, what these do is they don't stop the current. Resistors, they push back the current. So it slows the current down. So if you remember, we need resistors because we can't have all 5 volts going through our circuitry, or it might actually ruin it. So it slows the flow of the current. And remember, the current is just simply the electrons. So we're limiting the number of electrons that go in our circuit. Direction of current for LED with the anode and the cathode. And how to recognize the anode and cathode. We'll do this together. If you can draw this. Okay, the LED looks like this. There's a curved part, and then there's a flat part that sticks out. The part that sticks out is going to be corresponding to this portion, the longer one. This is the anode here. And over on the other side, the shorter one is the cathode. So when you're putting this in your breadboard, you're going to be putting it in, this goes on the left-hand side, this goes on the right-hand side, and you split it. The longer one has to go first. And the direction of the current is one way. So the current, or the electrons, I'm going to signify the electrons as E minus. The electrons come in, then the electrons are then going to come out. So it's a one-way, and if you have this backwards, it's not going to work. Breadboard identification, function, and the opposite sides. So identification, this is a giant whiteboard. So it's the giant whiteboard, okay, towards the front of the Bobot. The function is we're going to be attaching, and we have attached some sensors, such as, or the LED lights. We're going to be doing speakers very soon as well. But this is for sensors and for circuitry. So the function is we have sensors and circuits or circuitry. So I'm going to do a quick sketch of the whiteboard. And if you remember, we have 2 halves of the whiteboard, and these halves are independent. So each half is independent of each other. So this side does not connect to this side unless you actually connect it with the circuitry. So each side is independent. If we didn't have this breadboard and we were trying to make our circuits connect, how they do this in electronics is they have to solder it or they have to weld it. So they'll have a wire, they'll have another wire, a heated wire, which is going to be melted onto that, and then it sticks on. But we don't have to do that because all of our circuitry is going to stick inside these little sockets. And these little sockets are connected to each other in a row. So the sockets are going to be connected to each other in a row. So these are the sockets right here. So remember, we got 5 of them. So the sockets, just going to draw an arrow. We've got 1, 2, 3, 4, 5. Again, these are all connected. Okay, so if you connect to one, you connect to all five. So if a wire goes into here to power it, it powers all five. So connecting to one connects to all five of those sockets. But it does not connect to the other side of the sockets because remember, each side is going to be independent. How do the sides of the breadboard connect to each other? Well, let's go ahead and draw another set of sockets. Okay, and we're going to draw an LED, okay, not to scale. Okay, there's the anode, here's my LED, and there's my wiring. Okay, and then I'm going to have some type of wire coming in to power it, and then I'm going to have some type of wiring that's going to go over here to the ground. So we can connect both sides to each other with the circuitry. So how sides of breadboard can be connected? The circuitry connects the two sides. Circuitry can connect the two sides. So this is part of a circuit. So wire comes in, powers all these, the electrons flow through the LED, the electrons flow through the wire, they go back to the ground, they go back to the battery. Now we have a 0, a 1, and a 2, and which is the on switch. So this 0, this is going to be the off. The 1 is going to be used for when we program things. So you can program it, and then you verify it, and then you run it, you send it to the actual board with number 1. But number 2, this is when we're having movement. We just did this with our servos. You can't have the servos running on 1. They need to be on 2. So if you want your robot moving around left and right, forward and back, it has to be on 2. Okay, those are all the multiple choice questions. The short answer questions deal with coding. Now, you're not going to have to write an in-depth code, okay? In a lot of these questions, it's going to be, the code is going to be written for you, and you have to interpret what it means. Okay, so for example, how do you code an LED for on or off? So this uses the command high and low. So you're going to have high, you're going to have low. You're going to have digital write high, digital write low, and it's going to be in either number 12 or number 13, and then you have to indicate, okay, power is being sent to number 13 to send it on. Well, what do you have to code for it to be on? You have to have the digital write, and then you have to have a pin number, and then you also have to have either a high or a low. Okay, so your high, when you code for the high turns the light on. When you code for low, this is going to turn it off. Okay, and also if you have some type of delay, okay, don't forget that the delay is not a pause. The delay is the time that each of these commands is held. So it's time to hold each of the commands. How do you code LED for a loop function, for on and off? So if it's in the loop, you're going to be using, again, high, and you're going to be using low features. And you don't have to write them high, low, high, low, high, low. What you can simply do is you can use them once, use the delay feature, and you can have them blinking. So you can have it high, and then delay that for 1,000, which would be for 1 second. And then you can have a low, delay for 1,000, which is a delay for 1 second. If that's in the loop feature, this will be going on and off, on and off, on and off every 1 second. So in this case, this will be blinking forever. Blinks forever. So if again you had a high delay, low delay, and that's in the loop feature, that's going to blink forever. Directions the wheels turn with 1700 and 1300, clockwise or counterclockwise for each wheel. So let's go ahead and draw a little robot down below right here. And I'm going to draw the wheels. I'm going to draw the wheels kind of strange. I'm going to draw the wheels like this. Okay? I'm going to draw the wheels like this. So here's the center and here's the center. Okay, this is going to be the top of the wheel. Okay, I'm just kind of trying to draw this as a 3D. This is what's touching the floor. That's going to be the bottom. So here's your ball back there. So this is touching the floor. Oops, we lost the lights. There we go. Okay, so this is the top of the wheel. Of course, that would mean that this is the bottom of the wheel. And if this is moving forward in this direction, okay, this wheel would have to be moving like this, in the forward direction. This wheel would have to be moving like this. Okay, so this is the top, and it would be sending this to go forward. Okay, how does it go forward? It's going to be going 17, this one is moving 1700, and this one has to be moving in the opposite direction at 1300 for it to move forward. Well, which direction is 1700 moving? This is moving counterclockwise. I'm just going to put counter over here. This is actually moving clockwise. Oops, can't get that. Counterclockwise and clockwise. So if this wheel were to move 1700, it would be moving counterclockwise. So 1700 is always counterclockwise, 1300 is always clockwise. It doesn't matter what side it's on, but it does matter, well, if you have a counterclockwise and a clockwise, that's going to be sending it moving forward. What will make this move backwards? 1300, 1700, when they're moving in the opposite direction. In that case, the left wheel is moving like this, and this is going to be moving in a clockwise. So you should actually try to do this, okay? These are moving like this, okay? Just kind of try to rationalize this. Hopefully you can see that, okay? The left wheel, if I kind of look at that left wheel from the outside, that's moving counterclockwise. If I look at this one from the right-hand side, this is moving clockwise. So verify that for yourselves. Don't just memorize these things. These things need to be sort of ingrained as part of your understanding. So forward and backward motion. So to move forward, we need to have 1700 for the left and 1300 for the right. Backward is going to be 1300 and 1700. Those are some foundations that you guys need to know. Last thing we're going to be looking at is going to be our pivots and our swivels. So with our pivots, one is going to be always 1500, because remember, a pivot in basketball, pivot is when you're moving all around, but one foot is staying in the same place. Remember, stopped is 1500, so one is going to be 1500, and we'll go over all those. Okay, so if I have 1700 and 1500, I can have a 1300 and 1500. I could have a 1500 and 1700, and I can have a 1500 and a 1300. Okay, so these are numbers that we'll be taking a look at right now. And 1700, 1500, what's happening? Well, if it's 1500, my right wheel is stopped, and 1700 is forward, so it's going to be going forward in this, but it can't actually go forward. This is going to prevent me, so it's going to be moving around like this. So yes, this wheel is moving counterclockwise, but if this is stopped and this is moving forward, the robot will actually be moving clockwise. So I'm going to put clockwise right there. 1300 and 1500. This is stopped. This is now moving backwards. So if it's moving backwards like this, okay, this is going to have a counterclockwise motion. Don't just memorize these. These are things that you need to know as part of this logical framework of all these motions. So if this is stopped and this is going 13, okay, you know, for example, I'm going to do this, okay? This is stopped here. This is going backwards. Okay, which direction is this rotating? It's rotating counterclockwise. Okay, now 1500, 1700. 1500, this is stopped, 1700. Well, 1300 is forward for this, so that means 1700 is backward, so it's going to be moving like this. Okay, that's going to be a clockwise motion. Okay, so 1500 stopped, 1700 is going to be a clockwise motion. And then 1500, 1300, 1300 is going to go forward. That's going to be counterclockwise in that direction. So again, don't memorize these, but these are examples for you guys. Last one, swivels. There's two types of swivels. You can have a 1700 right now, 1700. There's many more, but these are the ones that we're going to be going over now. And 1300, 1300. Well, what's the direction of the motion? This one's 1700, and if this is 1300 forward, 1700 is backwards. So this is forward and backward like this. So it's going to swivel. That's going to be a clockwise swivel. 1700 forward, okay, so it's going to swivel like that. Okay, 1300, that's going to go forward, this is going to go backwards, that's going to be a counterclockwise. Okay, don't memorize these, rationalize them. Okay, that concludes our study guide.